Good morning and welcome all, and thank you for joining today's AWRI webinar. My name is Matt Holdstock and I'll be hosting today's webinar. In this session today, we will look at the practicalities of managing botrytis in the winery and the different approaches to dealing with mouldy fruit. But before we jump in and make a start, a couple of quick reminders to anyone who's new to the AWRI webinar program. If you would like to provide a comment or ask a question, please click on the Q&A button on the Zoom toolbar, type in your question and click send to send it through. We will be running a dedicated question and answer session at the end of these presentations, but feel free to send in your questions at any stage. A reminder also that this session is being recorded and a link will be sent through to you later to view via the AWRI's YouTube channel, most likely later this afternoon. Now, for those of you who have just joined, welcome. Today's webinar topic is managing botrytis in the winery. Today, we're very lucky to have Helen Mccarthy, Michael Ivisovich, Adrian Coulter, and David Wallen contributing to this webinar. I'd also like to thank Robin Dixon, one of the AWRI's senior viticulturists, for her work in helping pull this webinar together at such short notice. So first up, today we have Helen McCarthy, who is the senior winemaker at St. Hallett Wines in the Barossa Valley. Helen has over 20 years winemaking experience and will present today to us on her experiences on handling fruit coming into the winery with botrytis infection. Thank you, Helen.
Always me. Sorry about that. Let me get my page shared. Thanks, Matt. Today, I was asked to really talk about winemakers' experience and also what, as winemakers, we can do in terms of botrytis in the vineyard. Right up from the front, I'm going to say you need, as a winemaker, we need to be working extremely closely with our viticulture colleagues. I've learned so much over the years from the viticulturists that I've worked with, and I've been pretty lucky with the people that I've been able to work with. If we work together, then generally we can get through most issues. Really important, if you think that you have any disease in the vineyard, to be out visiting regularly. Now that's always a challenge during vintage, so therefore working with your viticulturalist really does help. They can point you in the direction of where they think there's a problem. Walk the rows, have a look. There are some methods that you can use when looking at vineyards, and I would suggest that if you're not using or you're not aware of some of the analytical methods for vineyard assessment, that you actually have a look at some of the literature out there. There's some really good books. My team here, we're going through a process of calibrating, so all the winemakers and viticulturists here are actually going through a calibration program at the moment, so that we're all looking at the same, we're all rating the same way. I guess the biggest thing with botrytis is whether you pick or not once you actually find it in the vineyard, and I'll talk about some of the methods that I've used in the past. You know, you've got to weigh up your risks of, if you pick this fruit, is it going to produce wine of a suitable quality for the price you're paying for those grapes? Are you going to be able to make quality wine? Are you going to be left with brown wine in tank? All of those things. But you need to do that in a scientific way. Obviously, we're not here as winemakers to put growers out of business. We need to work with our growers. So if we can do it in a more scientific way, I think it really does help the winery, and it helps that relationship with our growers, which is one of the most important things that we've got. So you need to also be aware how you, as a winery, can handle botrytis infection. So the other presentations will go into some of the more practical methods of managing botrytis in the winery. But from my point of view, if botrytis is so bad and you can assess it in the vineyard, then perhaps that decision should be made that you don't bring that fruit in. Now that is very much a winemaking, not an accounting point of view, but hopefully, you can work with your owners and the bigger corporate bodies to make the best decision. So some of the considerations: variety. Obviously, we all know that some varieties are more susceptible to botrytis, and the effects can be much more obvious. The style of the wine that you're making, you need to consider that. The time taken from processing to from harvesting to processing can affect the the impact of what botrytis is going to do to the fruit and therefore the wine quality. Very important to have a look at incidence versus severity. So they're very different, and in my last slide I'll talk quickly about the difference between incidence and severity. And you need to think about what additions you can potentially do in the field. So some of the things that I tried in 2011, I was in Clare in 2011, which was an interesting vintage because botrytis affected not only whites but reds. And we tried sulfur additions, we tried tannin additions. There's things that you can do, but obviously that's varietally specific. When you're making a Riesling, you're not going to be throwing a lot of tannin at it. So some of the things you can do when you're bringing the fruit in, just, you've already been out there, you've assessed whether the fruit has a suitable, the fruit is okay for you to actually manage. There's some evidence that some selective harvesters can help. Hand pickers, great way of bunch sorting. Your manual sorting tables and your optical sorters. Now, if the botrytis has gone too far, then obviously these methods, the only method really that's going to provide is almost hand picking and optical sorters or manual sorting tables. If it's too far, then the discussion needs to be had whether you even bring that fruit in. So we always come back to that. So when you're doing the assessment, you need to, it's very easy to go in and find a bunch with botrytis and freak out, and everyone says, oh no, we can't possibly take this vineyard. The viticulturalist will be saying, well, what's the incidence? There's one berry on every bunch, therefore there's 100% incidence, but it's only a 10% severity. On the other side, if you've got one bunch in 10 that is extremely, is completely rotted, then you have a 10% incident and a 10% severity. And one of the things that I've learned is that you need to be on the same page. Everyone needs to be talking in the same way about incidence and severity so that you can actually scale. The other thing, another technique that I found quite useful was doing Lackage tests on maturity. So the last maturity before it came in, that was a handy way to sort of see what the level of lactase we were getting through the fruit and making decisions. The decisions that we made were based on incidence, severity and a lactase reading. Again, you need to be working as a team to actually assess that and be comfortable as a winemaker that you're getting the right information. If you're not able to get out there yourself, you need to be reliant on your team of viticulturalists and technical assistants to be all over it. So understanding where they're coming from as well as what you need is really important. So I guess my main message is really work with the viti team and your growers to assess it properly. That's me, so I'll jump out and hand back over to Matt.
Thank you, Helen. Our next speaker, our next presenter is Michael Ivisovich. Michael is a fourth generation New Zealand winemaker from a pioneering wine family whose traditions still continue today. Michael completed his winemaking degree at Charles Sturt University in Australia and has worked in Clare Valley, Yarra Valley, Hunter Valley, and Michael began his career with Delegate 26 years ago. As Group Technical Manager of Viticulture and Winemaking, Michael was responsible for Delegate's viticulture and winemaking technical program and capital projects. Today, Michael will guide you through the challenges botrytis creates in the winery, but more importantly, from a practitioner point of view, how to manage this and what strategies you can implement with both white and red processing. So Michael, over to you. If I can just get you to share your screen.
Hi, Matt. Thanks very much. Sorry about that. Just a very quick overview about Delegate. Established in 1947, and New Zealand's #1 wine exporter to the world. So we harvested 36,500 tonnes last year, of which 5,500 were red, made up of Marlborough Pinot Noir and Hawke's Bay Merlot, and 31,000 tonnes of whites, which Chardonnay from Hawke's Bay for sparkling wine, Pinot Gris, Chardonnay for table wine, and Sauvignon Blanc, obviously. So within our range, we only have one wine in each variety, and we don't have any tiers. So it's really important for us that we can address challenges with botrytis, especially in a cool climate. So it impacts our wine styles by modifying and reducing our fruit flavours, and the wines become quite cooked and syrupy and caramelised. We get increased sulfides because we operate under more reductive conditions with higher SO2 and lower oxygen in order to protect that flavour. And we get mould related flavours. We often describe them as orange peel or pithy that can dominate the aroma in the palate. We have decreased density in our red colours. We have premature browning that can show up in both reds and whites. And in our reds, we often get anthracene and tannin imbalances. It impacts the aging potential of the wines as well. We find the wines age a lot faster and they have less obvious fresh fruit flavour. From a processing perspective, there's quite a big impact. We can have difficulties processing Botrytis-affected fruit, destemmer issues, press issues, draining red fermenters, filtration. So we have to use additional fining agents. We create additional waste streams. We use additional energy when we heat treat the wines, obviously additional operations in terms of time and labour, which all adds up to extra cost and capital, plant and equipment as well. So as a brief overview, previously, a number of years ago, we were operating everything on VSP canopies, anything from 2 to 4 canes, depending on the vigour and the soils. We would machine harvest them. We would add solid PMS addition to a gondola or a truck in the vineyard. We wouldn't control the temperature, and we'd bring it in and we'd cold settle it, which took quite a long time, using the cooling purely from the tank jackets and gelatin Bacchus to assist the settling. And then we'd store the wine throughout the year at ambient wine temperatures. So with a big review, we started in the vineyard, and I know Helen's already talked about the vineyard, but it's really important to us, so I just want to cover it off very quickly. We've retained VSP for anything that's on 2 canes. If we've got a little more vigour, we'll go to a smart Dyson canopy, and then on anything with 3 or 4 canes, we've gone to Scott Henry. What that does is it brings us significant improvement in the canopy openness, and it exposes the fruit a lot better, and it maximizes spray coverage, and it minimizes any dampness or moisture that we get, so our botrytis levels are greatly reduced. We do a very thorough pre-harvest pest and disease assessment, which Helen talked about, where we look at significant number of bunches and we put them on a scorecard, and we know exactly what our incidence and severity is on the block. So we're not dealing with people wandering through just looking at it and having variances in terms of calibration. We go through and we do a hand cleanup if required. With the number of tonnes we've got, it would be great if we could hand harvest everything, but that's not practical. So we have a limit of 3%. So if we have 3% severity, we'll go through and we'll clean up any bunches that are heavily infected with botrytis. It's a pretty tough measure, because what happens is we typically drop a lot of fruit, and we can lose a lot of crop. We machine harvest at night as much as possible. We've moved to liquid PMS addition for SO2 addition on the harvester, and we chill the fruit, or if we can't chill the fruit, we chill the juice in line from the press on the way to clarification. For our reds, we would warm in line to the fermenter, or we would use a flash détente system if we have extreme cases, to remedy both rain dilution and extract mouldy characters from the fruit. So our big change in white processing has been to move to flotation, which has been very effective. And then we use ceramic cross flows to filter those lees. Post-fermentation, if there's any wine which is showing lactase activity, we will heat treat or pasteurize that. And then we store the wines in temperature controlled storage. So I've just put a couple of photos in. I'm sure everybody is well aware of what a must chiller looks like. In our smaller batches, we would use this, which is a batch flotation unit. This is an absolute godsend for dealing with Botrytis-affected fruit. And on a larger scale, we've got more significant volumes. We are using continuous flotation units, which process through at a minimum of 20,000 litres an hour each. On the left, we have the photo of our heat exchanger with a regeneration section, which we use for heat treating the wine. And on the right, there's a photo of a holding tube so that we can maintain the temperature. So just a quick look at the Bacchus Botrytis model. I'm not sure how many of you will be familiar with that. We run this in each of our vineyards, and every time we get a Botrytis infection event, it will log, and we look at anything over a risk index of 1, and it shows up as red, and then we accumulate those risk indexes. So this is only a snapshot of the 2020 harvest in Hawke's Bay from November through to April. We had 8 events for the entire growing season, and cumulatively the risk index was 10.5. Now, 10.5 is really great. Anything under 20 we think is fine. 20 to 30 is quite hard work, and anything over 30 is something that you don't really want to experience. Which brings me to 2012 in Hawke's Bay, where we had 24 events and a cumulative risk index of 48. So harvest was in the March and April period, and we saw 5 of those events during harvest, which are those big red bars that you see on the bottom right. What that looked like, there's our harvest dates. So 15th of March we started and we finished on the 22nd of April. You can see in the blue bars there were some significant rainfall events and over 50 mils for 2 days in a row, and then a third day there with about 20 mils. So quite warm temperatures as well. You can see the mean air temperature and the maximum air temperatures during the day are still around the 20 to 27 degrees. So hopefully we don't see another one of those again. In the last 13 years, we've seen 1 of those. We would typically see Botrytis severities from 0.5 to 1.5%. That year we saw above 5. So in the vineyard, very quickly, open canopy, we ensure we set up individual sprayers. We've got a number of sprayers which are the same, but irrespective of setting them up the same, they all perform slightly differently with age. So we do every individual one and check it, and we check coverage using sunscreen. We obviously minimise infections to ensure that we've got the effective sprays on at the key times. We'll do a pre-bunch closure trim and pluck to ensure that that last spray gets on perfectly. And we review that Bacchus Botrytis model for a number of weeks before harvest so that we can see if we have a problem coming. We'll spray late infections during harvest with PMS. We have to keep in mind that it has to be dry in order for that to be effective. We'll hand harvest if possible, but obviously the cleanup I mentioned before is the real practical solution for us to achieving a great outcome. And the accurate pre-harvest pest and disease assessment ensures that the winemaking team have an effective plan to work with. If slip skin is present, which is a further advancement of Botrytis, we have to consider harvesting very quickly or we'll risk losing the fruit. So we harvest at night time or we chill. The temperature will depend on whether you would be cold settling or floating. We maintain above average SO2 levels during harvest, add tannin to reds to minimise our anthocyanin oxidation. We limit our skin contact time, so we want to make a very short turnaround from harvest to crush, and we also want to ensure that the juice gets out of the press quickly, so we can reduce our free run cut volumes. We'll add additional SO2 at the crusher. We'll increase our pectinase enzyme levels so that we can get that juice out of the skins faster and reduce the press cycle time and therefore the skin contact time. Obviously, we're not using enzymes with cellulase activity that will extract more juice from the skins. We're minimising the mechanical processes that macerate the skins as much as possible. If we don't do that, we tend to release glucans and have issues with juice viscosity and settling. So practically speaking, that means taking the crusher rollers out or opening them right up in the crushers, minimising press rotations and reducing our press times. We continue to maintain free SO2 in the grape skins during pressing. We keep our press fractions separate and we apply appropriate fining for each parcel so that we can remove any mouldy or dirty flavours. We ensure that we press and clarify the juice and start the fermentation as quickly as possible. So that's where the flotation is a huge benefit for whites. For reds, we don't cold soak under those conditions, and we would heat treat extreme batches through a flash détente system on the way to the fermenter. If we've got mouldy flavours, we would fine with skim milk or gelatin or tannin or PVPP or carbon, being aware that obviously carbon has quite a broad spectrum grape removal effect, so that's the sort of least preferred. Flotation obviously is very fast, but we still need to ensure that we get good clarity to remove the off flavours. Cold settling, if you're doing that, which we don't do anymore, we would recommend at least 50% of your final protein stability amount of calcium bentonite just to help absorb the off flavours and assist with settling. So bentonite is your friend. We would, where possible, if we still have issues, pass the clarified juice through a flash détente vacuum to remove any existing or any remaining flavours, keeping in mind that we're maintaining free SO2 at all times. We then inoculate with active dry wine yeast, so we've got a good active cell count of those. We'd avoid indigenous fermentations and just get it fermenting, keeping in mind that Botrytis will also reduce available nitrogen and micronutrients. So we need to ensure that we check our nutrition levels in the juice and boost those where appropriate. When we've got red wines, we'd obviously be adding tannin and maintaining good pH control as well. And we ensure that we try to limit the amount of oxygen that we're putting into red ferments. So instead of using a pulse air system for turning red fermenters, we typically revert back to pump overs. We get those red ferments quite warm, ferment them quickly and get them pressed off earlier than usual. And then once our red and white ferments are dry, but before we add SO2, we've got a very simple technique that we use where we just leave a sample on the bench overnight. We leave one in the fridge as a control, and we look for a brown layer at the surface of the bench sample. And that's, we found, a very, very reliable indicator. And if we see that, we would put that wine through, we'd put it straight through a heat treatment. We use 65 degrees for 30 seconds. I know the AWRI winemaking fact sheet on Botrytis is very good. It's a time-temperature relationship. So obviously higher temperatures, shorter time, or lower temperatures, longer time to achieve the same outcome. And then post-ferment, obviously maintaining good levels of free SO2, additional findings if required, casein, skim milk to remove not only phenolics or off flavours, but any browning that we're seeing in the wine. And if we've got filtration issues, we'd use glucanase enzymes, avoid allergen, not put the wine to barrel. So there's an example of the browning that we'd see in the top of a bottle. If we've got lactase issues, and those wines would go for heat treatment. The next set of samples that you see on the bench, there's 3 of them, for 3 pairs. The 2 on the left came in with 6% Botrytis severity and needed heat treatment. It was heat treated, so the second bottle is post heat treatment. So that wine became stable, and the other 2 wines, whilst slightly different in hue, both had 2% Botrytis severity. So it just goes to show it's not necessarily darker the colour is the higher the severity. We would heat treat any wine that's showing browns on the bench. So in summary, have a plan, make sure that your vineyard assessment is accurate and objective. Try and eliminate or reduce the Botrytis levels in the vineyard before you harvest it. Make sure you add SO2 on the harvester and at each stage in the winery. Increase your pectinase enzyme rate at crush. Do press cuts, do fining, use bentonite, clarify well and quickly using flotation if possible. Inoculate as soon as possible. Ensure that you've got appropriate nutrition, and heat treat the wines straight after fermentation if they're showing browning. Obviously avoid ullage and barrel after that and keep your free SO2 levels high.
Thank you, Michael. That was great. Our next presenter is Adrian Coulter from the AWRI. Adrian is a senior enologist at the AWRI who started working in the wine industry back in 1980. Adrian's role here at the AWRI is at the coalface of the AWRI help desk, working with winemakers on a daily basis, providing technical support and solving winemaking related problems that winemakers encounter. Today, Adrian will guide you through what tests you should be doing in the years when Botrytis-infected fruit finds its way into the winery. So I'll just get you to share your screen, Adrian, and over to you.
Thanks, Matt. So basically we're looking at lactase, which is an enzyme excreted by the Botrytis, presumably to oxidize the phenolic material, which I guess is an antimicrobial towards your microorganism. Now, it has been reported that when there's Botrytis infection, there's always going to be lactase there, and you might have heard of quick sticks, which is a good measure for Botrytis infection in grapes, but it's not necessarily a good indicator of actually lactase activity. We looked at this in quite a lot of detail of comparing methods back in 2011, 2012, and yes, of course, there is a bit of a correlation, but it really is quite variable, and it seems to depend on the variety. So you could get a low percentage of infection of Botrytis, and you might just get a low lactase activity for Cabernet, moderate activity for the same measure of infection for Shiraz, then a high lactase activity in Merlot. So yeah, as I say, it's quite variable. So you can't really sort of correlate too well the degree of infection with the amount of lactase activity. You really do need to test. And why do you need to test? Well, because lactase can cause serious oxidative damage, as you're probably all quite aware. So you should really test juices from Botrytis-affected fruit just to check the lactase activity, to see what that is, and so you can take measures to minimise the damages, as Michael was saying, gas cover and those sorts of things. And I would also suggest to testing it after fermentation as well. We found 2009 and 2011 sometimes people reporting that lactase activity seemed to go up after fermentation, but then when we looked at that closely with more than 100 samples, we found sometimes it goes up, sometimes it goes down, so it's quite variable. Okay, so there's a simple qualitative test you can do, and basically you just pour a couple of glasses of the sample you want to test, put one in the fridge, and so the cold temperature fridge is just going to slow down all the reactions, including the oxidative reactions, and then the next morning you can compare the two. And for juice, it might look something like that for the one that's on overnight if there is lactase activity. In wines, you also tend to get this kind of like oily film over the top as well, on the top of the wine, which I once looked at, and it appears to be, it didn't seem to be any kind of microbial thing. It was more like a colloidal thing, which I think was probably oxidized fatty acids. Okay, so there's that simple overnight sort of bench test to give you a rough idea whether you've got an issue or not. But there are also commercial kits available, and they're fairly easy to use, and especially the Botrytis one you can take out actually and do in the field too if you want to, because it's got quite a good kit form. So the kits that are available, there's two main ones that are available, based on the oxidation of syringaldrazine. So that goes to a purple colour. And as I said, you want to test that juice stages straight after fermentation, preferably a sample that doesn't have SO2. So before you add SO2, if you're talking about juice, then that's the best time to do it, because SO2 can interfere with the oxidation of the syringaldrazine, and you might get a false negative test. And straight after fermentation, of course, all the free SO2 should be bound, so that shouldn't really affect the analysis. So the two kits that are available, you've got the Botrytis kit and the Dolmar kit. Now, they both use syringaldrazine, but they seem to use a different scale. So the Botrytis kit uses activity units per mil, whereas the Dolmar kit just uses activity units. So because they're using the same compound to change color when it oxidizes, it goes that purple color. Of course, they're both going to have a similar kind of color chart. So the way you do is that you do the reactions according to instructions, and then compare your sample against the color chart. So the thing that you first notice is that in the Botrytis, the scale is 0 to 20 units per mil, whereas the Dolmar, the scale is 0.2 to 1.5 units. So really, any kind of color change to pink sort of development is indication of lactase activity, and you really should be careful, because that's indicating a risk of oxidation. Of course, the darker the color, the bigger the risk. What we found in 2011, the main issue was with reds. So whites there didn't seem to be any problems with, but with reds, particularly Shiraz, that tends to be highly coloured, you could possibly put it through the kit, and there might actually be some pink colour to start off with. Then it's pretty hard to see a change if you started with pink and then you get more intense pink. And sometimes people would decolorize with carbon, but I wouldn't. Whilst that works to some degree, you have to be very careful, because that also seems to remove the lactase as well. So it's a bit of a double-edged sword. We recommend using polypyrrolidone, PVPP, if it is highly coloured, to do that first, but I'll mention that again shortly. But these tests, because they're based on this change of colour of a compound, you can actually do this using a spectrophotometer. So there are methods out there for doing that too. Big wineries might be set up to do this, where you get an actual, instead of just a colour chart indicating a discrete sort of number, you can use a spectrophotometer and get a range of results, sort of a continuum rather than just an integer kind of result. So yeah, Patrick Collins' book has a method for that. So as I mentioned, deeply coloured reds, particularly Shiraz in 2011, tended to be the problem interpreting the results, and we had literally hundreds of calls about this in 2011. So if you do put the sample through the analysis and you find that it's coloured before you've even started the reaction, then we suggest colorizing with PVPP before you put it through the test. And we found like the best one that seemed to perform the most without removing so much lactase. What we really think is that the lactase is actually binding to the phenolics to some degree. So when you remove phenolics, you're also removing lactase. But polyclass seemed to work really well, and we sort of suggest 0.5 grams per 10 ml for juice, or 1 gram per 10 ml for wine before you put it through the test if it's, like I say, if it's still coloured. Now, as I said, SO2 interferes with the oxidation reaction of syringaldrazine, and has been suggested you can add peroxide to get rid of that sulfur, or maybe acetaldehyde to bind it. Now we tried that, and variable results. It didn't always seem to work. I would say try to get samples that don't have SO2. So like I said, in the juice stage, before SO2 is added, and directly after fermentation when you know that all the sulfur is going to be bound up. We even tried stoichiometric H2O2 and acetaldehyde, just to say it didn't make too much of a difference. Just bear in mind that if you do get a result, the chances are the true result is going to be higher. It seems that the test kits seem to underestimate the activity, and the way I know that is because we actually got Lactase enzymes and added to model wine and tested it against real wines, and the model wine you always get a higher result. So the things are kind of binding up that enzyme, which is logical, I guess. Enzymes are proteins, and phenolics bind proteins, and this is why it's probably a bigger problem in reds. So I tend to use the term apparent activity. So what you're measuring is more or less an apparent activity, not the real activity, because you do a test, and you get a result of, say, 4 units activity. If you leave that sample overnight, come back in the morning, you'll find that activity result is much higher. So the reactions still keep going on. They just slow down, I think. Other tests you can perform, and I know gluconic acid is tested in France a lot, but I think it's probably a better measure of actual Botrytis infection rather than lactase activity. Glycerol, we found that correlated pretty well with Botrytis infection too, but also correlated with lactase activity. So here's a couple of graphs just to end up with. Not that great down at the low levels. Down here on both of them, not so good. So while there's a correlation, we're talking about pretty high X scale there. So you're better off using the lactase test kits because you want looking down at the low level, and they're all bunched together. Just as a comparison there, gluconic acid versus quick sticks, as I said, which seems to be a good measure of infection, and glycerol again was even better than gluconic acid, because gluconic acid can be produced by other organisms which might also be infecting the grapes, whereas glycerol seems to be more produced by the Patridis. So that's just a quick overview. I guess the messages are you really do need to test for lactase and act appropriately, and if you do still have lactase activity after fermentation, then probably need to pasteurize, which David Wallen is going to talk about in a little while. Thanks.
Thank you, Adrian. If I could just like to remind everyone, if you have a question for our panel or any of our presenters, please send it through using the Q&A button at the bottom of your Zoom toolbar. Our next presenter is David Wallen. David's winemaking career commenced in 1979, some 40 years ago, after completing a wine science degree at Charles Sturt University in Wagga Wagga. David is the Research and Development Manager for VA Filtration Memstar, with responsibility for technical support, training, research and development, and supervision of equipment design and manufacture. So today, David will discuss juice and wine pasteurisation and the types of technology available for this activity. So thank you, David.
And unmute and start video. Hi there. My experience with working with Patridis goes back to the 2011 year, and in that particular year we had we noticed some problems coming out of the sort of vineyards that we were inspecting, and I suspected we would need to be prepared for offering a service to deal with this problem. So I looked at the opportunity to get some gear going, and we put together some equipment based on some of the information that was available at the time. That information was based on some of the Wine Research Institute material, and in effect, we were looking at lactase inactivation principle based on some of the data that was available, and that was that you needed to heat your wine or juice to greater than 50 degrees and perhaps 270 degrees. And what was basically understood at the time was the higher the temperature, the shorter the time. We found ultimately some data that suggested that holding time is an exponential function of temperature. The time is related to the temperature, and we found some data from Bolton that was published in an AWR seminar presentation, and what is shown on that graph is in fact two curves. The red one represents the Bolton data. We built some equipment and built into the control system for that equipment an algorithm for basically controlling the time temperature curve. And I'll show you how that worked in a moment, but in effect, the blue curve represents the system algorithm and that's built into the equipment. And what it shows is a more conservative approach. So for any given holding temperature, and we would typically work between 55 and 65 degrees, our holding time was somewhat longer. How do we actually implement that? Well, we had built, and here's a schematic of some of the equipment that we're using, a very simple process where we have a water loop, water gets heated up to approximately 80 degrees, goes through a heat exchanger, wine comes in, gets filtered through a bag filter, it gets taken up to somewhere in the order of 60 to 65, it goes through a holding loop, which I'll show in a moment. Typically this is around about 30 meters in length, and it contains 30 litres or 20 seconds of holding time at 6,000 litres per hour. So the red loop is the wine, the green loop is the water. Very typically the hot wine, in fact, coming out of the system pre-warms the cool wine coming in, and in fact gets returned. So this is a very energy efficient process that we developed, and in fact you'll see from the equipment, which is quite compact, that it can be done with just an instantaneous gas heater. The tubes are shown here, and they are in fact insulated, and there are a number of pumps and control systems. There's a heat exchanger on the system for controlling that, for getting the efficiency going, and we have treated, in effect, many millions of litres. Our options were in the winemaking situation, whether you treat juice or must. Well, that's been discussed previously. Certainly, there are some real practical issues for rapid heating and cooling of must. Flash détente equipment is certainly applicable, but not very few wineries have it. And there are certainly vintage scheduling issues in that. And generally speaking, these are somewhat energy inefficient processes. Wine certainly is a more interesting and a more applicable process for in most cases. Then your choice of when you do this heat treatment is whether it's pre-malolactic fermentation, in which case you have some issues, as we've been discussing, of getting the wine clarified, SO2 management, and then in effect any bugs that are there are killed off in effect by that, so you have to inoculate afterwards, or post-malolactic fermentation, in which case you have issues of storage, SO2 management and the like. If you do that heat treatment, there is an issue with regard to settling and clarification, so you may need subsequent pectinase addition. Some of the quality considerations, well, some of that has been already discussed quite effectively. The simplest test, pre and post treatment observation and tasting. From personal and anecdotal experience, that's a rapid browning is virtually eliminated. So in effect, take 2 glasses, one pre-treatment and one post-treatment, and you can see very, very clearly that left in the atmosphere, the control that in effect pre-treatment very rapidly browns. The treated wine is basically retained this colour, and they're relatively minimal sensory impacts. Of course, we've discussed the Lactase tests. One of the big problems in 2011 was the availability of these. There were long lead times to try to get hold of some of these kits after harvest. And it was one of our problems, of just getting hold of enough of those kits to be able to verify some of the work that was being done. From what we did, we found no record, or certainly from my recollection, no fails in using this process. So that curve that we used would appear to be quite applicable in general. And the only other option, the other issue that I'd like to just quickly mention is that the other rain effects, of course, are dilution. And even when not Botrytis affected, this was a problem for a lot of 2011 wines. And one of the options that's available for wines that are somewhat attenuated because of dilution was a concentration process by membrane filtration, reverse osmosis or nanofiltration. Certainly very useful for red wines. Many red wines were treated this way, not particularly useful as a technique for white aromatics. One of the interesting things that we noticed out of the 2011 year in Tasmania, for instance, a lot of wines have been treated with some calcium sprays to toughen up the skins, give them some resistance to botrytis. What that ended up with a lot of wines with high residual calcium. And this calcium led to some instability problems that needed to be solved. So that's something certainly to watch out for if people are using that. But for now, I think that's all I have to offer. Thank you.
Thank you, David. If our presenters could just pop their videos on. There's been, just to remind everyone, if they have a question, just to send it through. There has been a couple of questions come through. The first one is to you, Michael. The question is, do you utilise any specific enzymes to aid cross-flow filtration?
We don't, and we typically find we're only cross-flow filtering the lees. We're not, we call them fleas because they're the floated lees, and they typically go through very well. We do ensure that the wine is pectin negative before it goes through the cross-flow though. So if it's not pectin negative, we would make an additional add of that pectinase to ensure that it was stable before we could filter it, or float it and then filter it.
Okay, and there's another one on the Gallic acid concentration or the rates that you use in your reds. Can you just explain a little bit more about the Gallic acid additions? And additions, sorry.
Yeah, so that's quite new for us. So we've been fortunate enough to have a couple of good vintages on reds in a row. So we'll have to go back and just have a review of those notes, to be honest.
And with reference to David, just a question from me, with reference from David about calcium instabilities, I think in one of your slides you mentioned calcium bentonite was your bentonite of choice for settling. Is there a reason that you're using calcium as opposed to sodium or a mixture?
So I think, yeah, that was me. We were using calcium bentonite just because it's more compact. So we get less lees to filter.
Okay. Question for you, Adrian. The Botrytis testing kits, there's a question on the use by dates on these. How long do they last for?
Oh, that's a good question. I'd have to look that up. But I know that, like, for example, commercial services here, I think ordered a number of kits in November for this vintage. So it must be a few months at least.
Okay.
Yeah, I'll look that up and get that back.
Sure. There hasn't been any other questions come through for the panel at the moment. Is there any questions from panel members to each other?
Just from our experience, we've been trying to measure botrytis or lactase and gluconic acid both in maturity samples prior to harvest and in juices or wines post-harvest, and we've found quite a lot of variability and a lot of false negatives as well, which is why we've really just come back to our quite simplified bench system. So I'm assuming from the things that Adrian was talking about, that's obviously quite consistent. Is there any way that we could be more confident about achieving a greater level of certainty around those results and a better application?
Just firstly, just answer the other question I just looked up. 18 months at 4 degrees, the kits last for. Okay, yeah, the issue that we investigated in 2011 was to do with red wines, with the false negatives and false positives. And for us, we found that yes, the treatment of PBPP before actually putting it through the commercial test kit seemed to solve a lot of those problems. We actually did look at another method where you got a different color change, which is out there in the literature using a different compound. I won't try and say the full thing, but the abbreviation is ABTS, and that goes a green color. But there's no commercial kit available for that. You can do it the same way as you do the syringe aldrazine using the spectrophotometer, but you just have a different buffer solution and used a different compound. But that actually is more sensitive. When we did our tests in 2011, 12, actually 13, we actually managed to get some Botrytis grapes as well. We found that is more sensitive than syringe aldrazine. And I've since found someone who did a PhD on this and looked at reactivities with Lactase, and the ABTS had more than twice the reactivity. So that kind of made sense of why we found the ABTS much better. But as I say, that you can't buy it in commercial form, which makes it a bit of a pain, and using a spectrophotometer in the middle of vintage it might be okay for a big company who's got a big lab, but for small wineries it's not that useful. Well, all I would say was, yeah, PBPP, and particularly the polyclar version seems to be the best, because we tried a few different ones and doing different rates. But carbon, yes, I wouldn't recommend carbon. When we started using carbon, the levels of lactase went down when we know that, yeah, we knew that they were actually still there. So it does seem like carbon removes it, but PBPP is kind of balanced between removing a little bit of the enzyme, but removing enough phenolics to make the test work better. So your false negatives or false positive, was it mainly to do with just the color change?
A little bit of that. We were also having some issues with whites, so the colour change obviously wasn't as significant an issue there. Mainly on the Dolmar test.
Dolmar, I was just going to say, which kit are you using the Dolmar? I mean, I don't want to sort of like knock brands or anything, but when we compared the ABTS versus the Botrytis kit and the Dolmar kit. The Botrytis was more sensitive than the Dolmar. That's just what we found. I guess you'd have to have someone else to repeat that sort of comparison. But what we found was ABTS was the most sensitive, then the Botrytis kit, and then the Dolmar. So there could be that, and especially down at low levels, the Dolmar wasn't always picking up, an activity when, say, the Botrytis was coming up with a 2 units per mil activity. The Dolmar wasn't actually necessarily getting anything. So that could be it.
David, there's a question for you regarding sulfur loss during, in your experience with using your equipment and the pasteurisation. Was sulfur lost more rapidly after pasteurisation?
We didn't observe that, certainly. We would expect the wineries to make an appropriate adjustment. Of course, if we were treating pre-MLF, they would be encouraged to quickly inoculate and not add SO2 first. But in effect, it was quite dramatic if you could see the effect of treatment and you just put the 2 glasses out as was shown. It was dramatic. You could see almost immediately a Botrytis-affected wine would start to go brown. Certainly within an hour, it would be very evident. And the wine that had been treated was basically had retained its colour. So you've got a bit more room to move in that sort of situation. Your sulphur addition is not quite as critical. And so certainly the opportunity to do that at your leisure is a bit more available. But certainly, the problem is in the lead up to it, because sometimes we wouldn't be able to get to sites quickly enough, and so those wineries had the problem of trying to maintain their wines in good condition. And so the key to that was, if necessary, some sulfur addition, and certainly keep the oxygen away by keeping them full. So that was the major challenge, just getting around to as many as possible. Going and doing that, offering that as a mobile service was the key, because most wineries just don't have that sort of equipment. And, the opportunity.
I can just confirm with David, it definitely does work, and experiences that I've had too, along with David and myself when I used the pasteurizer back before 2011, I think it was 2009, and then another winery that sort of set up their own sort of makeshift pasteurizer in a similar way by using different lengths hoses through to a heat exchanger. It definitely works. And as David said, yeah, the difference in the browning, the 2 glasses is quite amazing.
And certainly the sensory effects were nowhere near what you might expect. Certainly, I think wine is a lot more resilient with regard to heat treatment than we think. I mean, the interesting problem was we did some trials with a couple of the people at the AWRI on juice treatment, heat treatment for protein stabilization recently, well, a couple of years ago. And we certainly found more effect on heat treating juice, contrary to popular belief that, juice, it's better to treat juice than to treat wine. Our experience was that you got a more evident sensory effect from treating some of the juice than the wine. And it could be because of caramelization and Maillard type reactions. Not that we're going anywhere near that temperature, but certainly to do protein stabilization. Not that that actually worked, by the way, but you needed to go over 75 degrees. And we tried that, but not with huge success. There's certainly a project going on at the moment on that very subject. But heat treatment by itself is not a protein stabilization method. But that's just an aside.
Well, I just agree with David that the wine that I went to a pasteurizer and with a winemaker and measured the lactase activity as it's going through, and afterwards the wine, if anything, it almost looked a little bit better after pasteurization. Yeah.
And so I would certainly add that I think Adrian, you and I had some discussion 10 years ago about the sort of temperature and holding time issue. And I know the AWRI was based on some fairly limited
That's right.
tests and leading to somewhat more conservative recommendation.
That's right, yeah.
The more modest, I think the data that Bolton had shown in that curve that I demonstrated certainly seems to me to be more close to the mark than some of those initial quite conservative recommendations of much longer holding times and higher temperatures that are necessary.
Yes.
So I would suggest that somewhere between 55 and 65, even in that order of 60 degrees, is for anywhere between 5 and 20 seconds is probably more than adequate.
Yes, well, I would use the data you've got because that's probably the best data there is, really, that we've got available.
If the problem comes up again, we'd be more than happy to do some sample runs to just verify that and just test different temperatures and times and just actually see what happens. So if that does come up again, hopefully not, but if it does come up, maybe it's time to actually review some of that data and verify it with something that's measured and publishable.
Good point.
Okay. There hasn't been any more questions come through, so what we might do is we might say a big thank you to our presenters today, Helen, Michael, Adrian and David, for providing important insights into managing botrytis in the winery. I'm sure everyone who attended today got a lot out of the session. Just also like to thank the audience for joining in and taking part, and I'd like to remind you, as always, you will receive a link to view the recording of this presentation, which will be available on the AWRI's YouTube channel, most likely later this afternoon. Just like to also acknowledge Wine Australia for providing funding and support of the webinar program via the AWRI Extension Project. Just like to advertise the next webinar. That's on Thursday, the 29th of April. Dr. Anthony Borneman from the AWRI will present the origin of Chardonnay clones with historical significance in Australia and California. If you'd like to register for this session, please visit the AWRI website. That's all we have for you today. And again, thank you again, and look forward to seeing you at the next AWRI webinar. Thanks a lot.
Thanks, Matt.
Thank you all.
Thank you.